This video is focusing on the exact same plots we saw in the previous video, but now I want to highlight some pieces of when we're sketching a monoprotic weak acid. Now, if we were just given our pKa, we should be able to get a pretty reasonable sketch of a titration without a whole lot more information. Now, if we just want to have some idea of what the behavior will look like. If we want to know what it really looks like, obviously we need to care a lot about concentration as well, because that can have some big impacts on how quickly we have our rise and everything like that. But if we're in a reasonable concentration, and we just want to know roughly what things should look like as we're planning out our experiment, we know a few of these points already. We know that when we're halfway to our equivalence point, pH equals pKa, as long as we're not in the really acidic or the really basic condition. Alright, so we're still in an intermediate range, so we can go ahead and fix this point in. Now notice we're going to be starting, and my quick rule of thumb for this, we're going to be starting on the more, acidic or basic end, depending on what solution we had. In this case, it's acidic. And usually what I do when I'm sketching it, I kind of go about a quarter of the way down from where our pKa is. So you can see that here at pKa of 6, I'd expect my intercept to be, using my quick rule of thumb, about like 4.5. And it's not a terrible guesstimate for where you're going to be when you haven't added any of your conjugate acid or base. So if you're just doing a fast and dirty sketch, that's not a terrible way to do it. Now as far as you go for your rising portion, this is going to basically be a straight line going vertically. And then once you get past your equivalence point, all that you've got now at the equivalence point is salty water, with a pH of something like 7 at some point. Now if you actually are in a more basic solution, you're going to have it drifted upward from there. So you can just have it kind of get sharp there, but what happens after that? You're just adding strong base. So for everything other than the most basic of cases that we have here, the curves are all going to look the exact same way. Here we have it different because after that equivalence point, we're still going to have an equilibrium condition establishing itself through systematic treatment of equilibrium and Le Chatelier's principle and the leveling effect of water and all that good stuff. But down here, pKa of 9 or 8, we're still okay. They're all going to look pretty much the same. At this concentration, we're expecting that going up by another 60% volume in terms of our titrant, we're going to get up to pretty close to pH of 12. So I usually just kind of sketch things out to level off somewhere around pH of 12. And as long as we don't have an unfortunate concentration to start from, we're going to have a titration curve that looks reasonable. So those are some of the estimations that you can make if you have to quickly sketch a monoprotic weak titration, or at least be able to identify which pKa goes with which plot, that sort of a thing.